Kata is something you practice, not something you watch. Read the lesson, write the code yourself, then review what you wrote. This video is the reference you come back to afterwards. A model can produce this code in seconds, and the reason to write it by hand is to keep the judgment that tells you whether the code is any good. useRef gets introduced as the hook for grabbing DOM elements, which is one of its jobs and not the interesting one. What it actually gives you is a box that survives re-renders and that React does not watch. Everything else follows from those two properties. It is where you put the things a component needs to remember, but the screen does not need to know about. And it is the answer to a question this course has been building towards since state basics. What do you do with a value that has to persist but must not cause a render? Call useRef with an initial value and you get back an object with a single property called current. Two things about that object matter, and both are easy to say and easy to forget. It is the same object on every render, not an equal object, the same one. So anything holding a reference to it sees your changes and React does not watch it. Assigning to current is a plain property assignment on a plain object. So nothing is scheduled, nothing re-renders, and the screen carries on showing whatever it was showing. That is not a limitation to work around. It is the entire point of the hook. The common case first. Create a ref, pass it to an element's ref attribute, and React sets current to the real DOM node once that element is on the page. Then you can focus it, measure it, or scroll it. Note the ordering because it is the thing that catches people. React assigns the node after it has committed the DOM, which is after your render function has finished. So during the first render, current is still null, and any code in the body of the component that reaches into the node will fail. Read a DOM ref in an effect or in an event handler, never during render. The second use has nothing to do with the DOM, and it is where the hook earns its keep. Anything the component needs to carry between renders that the user never sees, whether this is the first render, a socket instance, an ID from a previous request, a counter you are keeping for yourself. Put it in a ref and mutate it freely. The test is one question. If this value changed and the screen did not update, would that be a bug? If yes, it is state. If no, it is a ref. Tracking the previous value of something is the neatest small demonstration of the hook. Keep a ref and in an effect after the render has happened, assign the current value into it. Because effects run after paint, that assignment lands after everything on screen has already read the ref. So on the next render, the ref still holds the previous value, and by the time you write to it again, the render that needed it is done. It is a two-line trick that depends entirely on the ordering, and it will not work if you assign during render instead. Timer handles are the textbook case, and it is worth being clear why a plain variable fails here. A variable declared in the component body is created fresh on every render. So the start function and the stop function are looking at different variables, and the stop cannot see what the start created. Ref is the same object across all of those renders. So the handle written by one function is visible to the other. This is also why the stopwatch in the last playground can have separate start, stop, and reset buttons that all agree with each other. Scrolling is DOM access again with a different method on the end. Hold a ref on the target element and call scroll into view when you want to go there. Worth saying out loud that this is a legitimate use of reaching into the DOM. React's model is that you describe what the UI should look like and it makes that true, but scroll position, focus, and text selection are not things you describe, they are things you command. Those are exactly the cases where a ref is the right tool rather than an escape hatch. The table on screen is the decision, and it comes down to a single line. Does the screen need to change when this value changes? useState says yes and pays for that with a re-render and an update that you observe on the next render rather than immediately. useRef says no and gives you a value that changes the instant you assign it. That immediacy is worth noticing. Set state and read it on the very next line and you get the old value because the current render's variables never change. Assign to a ref and read it on the next line and you get the new one. Two different tools, and the difference is not convenience, it is whether React is involved at all. The list on screen is the honest summary of when to reach for it, DOM access for focus, scroll and measurement, timer and interval handles, previous values, and anything mutable that the UI does not depend on. There is one entry worth pushing back on gently, which is using refs to avoid re-renders. That is occasionally the right answer, and it is more often a sign that a value which does affect the UI has been hidden somewhere. React cannot see, so the screen goes stale and nobody can work out why. Reach for it deliberately, not as a performance habit. useRef gives you the same object on every render with one mutable property. Changing it schedules nothing. The ref attribute fills it with the DOM node after the commit, so it is null during the first render. Use it for DOM access, timer handles, previous values, and anything the screen does not depend on. And use state for everything the screen does depend on, because a value React cannot see is a value that cannot keep the UI honest. This variant is trying to count how many times the component has rendered using state, and it is an infinite loop. Read the effect. It has no dependency array, so it runs after every render, and what it does is set a piece of state. Setting state causes a render. That render runs the effect again. Which sets state again? Nothing here is subtly wrong. It is the loop written out in 4 lines, and it is the shape of a genuine bug that people hit while trying to debug renders. The deeper mistake is the choice underneath. A render count is not something the UI depends on, it is something you want to watch. Putting it in state means every observation changes the thing being observed. The same counter in a ref. It increments, it persists, the number goes up as you type, and there is no loop because assigning to current tells React nothing. One caveat that this variant is a good excuse to state since the code does it. Writing to a ref during render is something React's own documentation tells you to avoid, and rendering is supposed to be a pure calculation. For a counter that exists to be looked at, it is a well-known and harmless exception, and you will see it in a lot of code. 2 things to be aware of if you use it. In development, strict mode renders twice, so the number will be double what you expect. And if you ever need that value to be correct rather than indicative, do the increment in an effect instead. The last variant puts both halves together. The top part holds a ref on an input and focuses it from a button, which is the DOM case. React committed the element, set current to the node, and the handler calls focus on it. The bottom part is a stopwatch, and it is the mutable value case done properly. The elapsed time is state because the screen shows it and has to update. The interval handle is a ref because the screen does not show it, and nothing should re-render when it changes. Start writes the handle into the ref, stop reads it back out and clears it. Reset does both and zeros the state. Read those 3 functions together and the division becomes obvious. What is displayed is state, what is bookkeeping is a ref. The model to keep is a box that React is not watching. It is the same object on every render, so it remembers. Changing it schedules nothing, so it is silent. That makes it right for DOM nodes, timer handles, previous values, and private bookkeeping, and wrong for anything the screen depends on. When you are unsure which one you need, ask whether a change to this value should be visible. If it should, React has to know, and that means state. The kata is the part that matters. Open the lesson, write the code yourself, then read back what you wrote and judge it. The link is in the description, and that practice is what keeps the skill yours.